Hello everyone, welcome to the session. Today we are going to see few problems under this chapter, mechanics of a rigid body. Let us see first problem here. First problem is an electron is moving in a circular orbit of an electron is moving in a circular orbit of radius 5.3 into 10 to the power of minus 11 meter. 5.3 into 10 to the power of minus 11 meter. Around the atomic nucleus, atomic nucleus at a rate of 6.6 into 10 to the power of 15 revolutions per second. Find the acceleration of the electron, and centripetal force acting on it. The mass of the electron is, we know that Em is equal to 9.1 into 10 to the power of minus 31 kg. See what we are going to find in this problem. An electron is moving in a circular orbit of radius 5.3 into 10 to the power of minus 11 meter around the atomic nucleus at rate of 6.6 into 10 to the power of minus 10 to the power of 15 revolutions per second. Here I am taking electron. So the number of revolutions per second is how much? 6.6 into 10 to the power of 15 revolutions per second. Find the acceleration of electron and the centripetal force acting on it. Now let us see. We know that one formula, the relation between velocity and angular velocity can be written as here solution V equal to R omega. So how can you write this omega? We know that omega can be written as 2 pi f. Then V equal to R into 2 pi f. And so one more thing is the acceleration can be written as A is equal to V square by R. Right? A equal to V square by R. Substitute V value here. Then what we get? Then V value will get 4 pi square f square r square by small r. Right? Now r cancel. And then we'll get here 4 pi square f square r. Okay. Then substitute all the values in that equation. What we get? A is equal to 4 into 3.14 square into, and the f value is what? This one is f value. Substitute 6.6 into 10 to the power of 15 whole square, and here what we get? R value. What is R value here? Okay, radius of electron around the nucleus. The value is given here 5.3 into 10 to the power of minus 11. Okay, now squaring this one, then we will get answer is a equal to this one is 1.05 something, and squaring this one will get acceleration of electron is 9.1 into 10 to the power of 22 meter per second square. Okay, so towards the nucleus. Now the centripetal force, this is the acceleration of electron revolving around the nucleus, and the centripetal force Fc can also be written as m into A. The value of A is given there, mass of the electron 9.1 into 10 to the power of minus 31 kg into here the acceleration is 9.1 into 10 to the power of 22, and after solving this one we'll get 8.3 into 10 to the power of minus 8 newtons. Okay, so this is the centripetal force of the electron which is towards the nucleus. Now let us see one more problem here. Now the second problem is, see here, second problem, a car develops 75 kilowatts power when rotating at a speed of 1000 rpm, revolution per minute. What is the torque acting here? The power P developed by torque tau exerted on a rotation body is given by the relation between power and torque can also be written as, power can be represented capital P equal to tau omega, torque acting on the car, and where omega is angular velocity. Now, so from this one we will get tau equal to P by omega. Now, so what is power here? 75 kilowatts power. So this can also be converted into joules per second. See there, how can I convert? Here P equal to 75 kilowatts, and let us convert into joule per second, and we will get 75 into 10 to the power of 3, and watts, that can also be equal to 75 into 10 to the power of 3 joule per second, joule per second. Okay, now so we know that W, how can we write W here? W is equal to 2 pi f, where f is the frequency, nothing but revolutions per minute. So here we'll write 2 pi into f value can be what? Here you have to take in terms of seconds. So let us convert 1000 rpm, right? 1000 by 60 revolutions per second. So what we get here, 0 0, and what we'll get here, the answer is 100 into pi by 3 revolutions per second. Okay, and substitute these two values in above equation. What we get, tau equal to, the P value is what, 75 into 10 to the power of 3 by, and the W omega value is how much, 100 into pi by 3. So finally what we get, eventually we'll get the answer solving this one. Okay, so 75 into 3 and 10 to the power of 3 by 3.14 into 100, and here we'll get 1, and here is what we get here. Okay, 75 into 30, right? So by 3.14, finally we'll get tau equal to, the value is 716 into 3 Newton meters. So this is our resultant answer. So torque acting is how much? 716.3 Newton meter. So this is the answer. Now let's go to another problem. Now the third problem is a circular disk of mass circular disk of mass 100 kgs and the radius 50 centimeter is mounted axially and is rotating calculate the kinetic energy when it executes 25 revolutions per minute. See, the circular disk of mass 100 kg and radius 50 centimeter is mounted axially and is rotating. Calculate the kinetic energy when it executes 24 revolutions per minute. See here what I am doing. I am taking disk. This is the circular disk. I am taking circular disk now, which is rotating axially. Here we'll get take for example rotation like this. Now whose radius is how much? 50 centimeters radius. Okay, and now number of revolutions per minute, how much? Here 25 revolutions per minute, and whose mass is 100 kg. We have to find out its kinetic energy. Now the kinetic energy of rotating body can be taken as of I omega square. It is very clear, we know very well. And how about inertia? Now the inertia of this rotating disk axially can be written as mr square by 2 into omega square. Okay, now so what is omega? How can we write omega? Omega can be written as omega is equal to 2 pi f. Okay, so what is f? Revolutions per minute. So we have to write 2 into 3.14. And what about f value? Where the f value can be written as here 25 by 60 revolutions per second, okay, into f, and substitute all the values. So r also given there. R is equal 50 centimeters, convert into meters, then we'll get 0.5 into 10 to the power of 0.5 meters. Okay, right. Substitute all the values in above equation. M also given there. M is equal to 100 kgs. Now the kinetic energy equal to of into m 100 and r value is 0.5 whole square by 2, and omega square value is 2 into 3.14 into 25 by 60 whole square. Okay, we got this one. Now 1 by 2 100 into 0.25 by 2 into, so what we get here 4, and squaring this one 6, and 2 will get 9.6 into and 25 into 25 by 60 into 60. Okay, so finally we'll get here, solving this one, then we'll get the 3.85 joules. So kinetic energy of that rotating disk axially is how much? 3.85 joules. So in this way we'll solve this problem. So let us move on to next problem here. A sphere of radius, a sphere of mass 2.5 kg, 2.5 kg and a diameter 1 meter, rolls without slipping with a constant velocity of 2 meter per second. Calculate its total energy. We have to calculate its total energy. So write the total kinetic energy. You know that the sphere of mass is given there and diameter is given there. It rolls down without slipping with the constant velocity 2 meter per second, right? So when it is rolling down, it has two types of kinetic energies. One is due to the translatory motion, another one is due to the rotatory motion. So for this we have to write the total kinetic energy. Total can be written as kT, kinetic energy due to the translatory motion, and the kr, so kinetic energy due to the rotatory motion. So how can we write it? We'll write, we know very well, for translatory motion we'll write of mv square, and this can also be written as of I omega square. Okay, kinetic energy due to the rotating body. So what we get here, 1 by 2 mv square plus 1 by 2 inertia of that sphere can be written as about the diameter. This can be written as 2 by 5 mr square. So 2 by 5 mr square, and here, so omega in terms of velocity, angular velocity in terms of linear velocity can be written as v equal to r omega, and omega is equal to v by r. So v by r whole square. Right, finally what we get, 1 by 2 mv square plus, here we'll get 2 can cancel, and we'll get mr square by 5 into v square by r square, right? So here we'll get r square cancels. What we get of mv square plus, here we have term 1 by 5 mv square. So finally we'll get 7 by 10 mv square, right? So what is m? Then the total kinetic energy 7 by 10 into, so what is m value? 2.5 kg into what is v value? 2 meter per second, so 2 square. So what we get finally, 7 by 10 into 2.5 into 4, and we'll get finally 7 joules. So answer is how much? 7 joules. Okay, now let us see one more problem here. So let us see one more problem, fifth problem here. The speed of a particle of mass the of a speed of a particle of mass 20 kg 20 kg that is moving along a circular radius of 1.5 meter, increasing at the rate of 0.5 meter per second for every second. Find the torque acting on it. Let us see here. So speed of particle of mass 20 kg that is moving along a circular radius of 1.5 meter, increasing at the rate of 0.5 meter per second for every second. Find the torque acting on it. Now let us write L. This is what angular momentum. L is equal to mvr. We know this one. And rate of change of angular momentum is equal to torque acting on the body. Torque is equal to dl by dt, right? So let us take mv common and dr by dt. So what is dr by dt represents? Well, sorry, dv by dt. You have to write v here and you have to write v. Okay, r is constant. So mr into dv by dt. So here we'll write dv by dt is nothing but what? So here what we get, then the velocity is given there, how much? 0.5 meter per second, and here r is given there. So just substitute all the values in this equation. Right, see here, substitute all values. When tau is equal to mr into dv by dt. Right, what is m there? Given in the equation, mass of the particle is almost 20. What about r? Radius. So how much radius is there? 1.5. And what about the dv by dt value? dv by dt value is nothing but 0.5 meter per second for every second, right? Substitute this value, then we'll get 0.5, and finally what we get here, 0.5 into 10 into 1.5, then finally we'll get 15 Newton meter. The torque acting on the particle is almost 15 Newton meter. Now see here, one more problem. A 500-gram stone is revolved at the end of a 0.4 meter long string at the rate of 12.5 radians per second. What is its angular momentum? So we know that. How can we write angular momentum? L is equal to mvr, and we know that v can be written as v equal to r omega. Again we'll write, so we'll get m, if substitute v equal to r omega, we'll get mr square omega, right? So all the terms are given in the equation. So where m equal to 500 grams, so this can also be 0.5 kg, and r value also given there, 0.4 meter, and omega value also given there. Now substitute all the values. will get here, and here it is 0.5 and r square value is 0.4 into 0.4, and omega value is so much, 12.5 radians per second, 12.5. So finally what I get here, solving this one, and what we get here, so 12.5, 0.16 here, 0.16 into 0.5 into 12.5, and 75. So we'll get the answer is 1 joule second, 1 joule second. So angular momentum, its angular momentum is how much? 1 joule second. So next problem is 7th one. The kinetic energy of metal disk. The kinetic energy of a metal disk rotating at a constant speed of 5 revolutions per second is 100 joules. Find angular momentum of the disk. Find angular momentum of the disk. Okay, let's see here angular momentum. How can we write? So angular momentum L is equal to I omega, right? Now the kinetic energy can be written as kinetic energy of rotating disk is of I omega square, right? So from this equation we'll get I equal to 2 into kinetic energy by omega square, right? So we know very well, and substitute all the values. I equal to 2 into, what about kinetic energy? Kinetic energy is 100 joules by omega square. So what is omega square? How much is there omega square? The value of this one is, omega can be written as 2 pi, nothing but 3.14, and revolutions per second. So 5 whole square. So finally we'll get from this equation, so answer is, we'll get 0.2028 kg meter square. This is I value. And again substitute in our equation, so L equal to I omega. So I value is almost 0.2028, and what about W value is here 31.4. So we'll get finally answer is how much? 6.368 kg meter square and second inverse. Okay, so this is our required answer. Let us see next problem here. Problem number 8. Find the orbital angular momentum of moon about Earth given the mass of moon equal to 7.36 into 10 to the power of 23 kg. Average distance of the moon from the earth is 3.84 into 10 to the power of 8 meter. Period of revolution of moon is period of revolution of moon is how much? 27.3 days. Okay, 27.3 days. Now, so what we have to do here, we have to find out orbital angular momentum of moon about Earth. Okay, generally, so the equation can be written as we know very well, angular momentum L is equal to R cross P, where P can be written as R cross mv and RMV sin theta, right? RMV sin theta, but where the theta is equal to 90 degrees, that is why 90 degrees, that is why we will write L is equal to mvr. L is equal to mvr, and we know that V equal to R omega. Substitute in this equation M equal to V equal to R omega into R. Finally we will get M R square omega. So now, so substitute all the values in this equation. So what is omega? So omega is nothing but a 2 pi f. This can also be written as 2 pi into f can be written as 1 by t, time period, and time period is given there 27.3 days. You have to convert it into seconds. Then 27.3 into 24 hours into 60 into 60 seconds. So doing this, what we get, that is equal to 2.663 into 10 to the power of minus 6 radiations per second. Okay, after solving this one, now substitute all values in above equation. L is equal to m value is given there. How much is m value? 7.36 into 10 to the power of 23 kg, and here R value is given there. What is that R value? 3.84 into 10 to the power of 8 whole square, and mr square omega value is how much here? 2.663 into 10 to the power of minus 6. In the solving this, we'll get L is equal to 2.889 into 10 to the power of 35 joules a second. So this is the orbital angular momentum of moon about Earth. In the next class, we'll see few more problems, okay, regarding inertia, tensor, and also precessional velocity of symmetric top. Okay, so let us end of this class today.